The next question that we have actually has two similar questions as subparts. In the first part, we have been given two sound sources S1 and S2 vibrating in the same phase, and the detector moves along the circumference of the circle. We need to find out the number of maxima and minima captured by the detector. So for finding out this, let us see how much the path difference is at various points. If we look at this point, the path difference at this point clearly is 3 lambda, because the sound wave when traveling from S1 to this point has to travel an extra distance 3 lambda. Similarly, the path difference at this point is again 3 lambda, and the path difference at this point, which is perpendicularly above this point, is 0, because the sound waves traveling from S1 to this point, let this be K, S1 to K and S2 to K have travelled the same distance, therefore the path difference at this point is 0. Again similarly, the path difference at this point is 0. Now it always varies slowly, therefore the path difference at some point over here would have been lambda, and path difference at some point over here would have been 2 lambda, and it would have increased slowly to reach 3 lambda. Again similarly, it would have been lambda somewhere here, 2 lambda somewhere here, lambda somewhere here, 2 lambda somewhere here, again lambda here and 2 lambda somewhere here. So we need to find out the number of maximas. So the number of maximas clearly are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. That is a total of 12 maximas. Similarly, if we keep on the counting, we will have a minima here, and similarly if we keep on counting, we will have 12 minimas. At here the path difference will be somewhere lambda by 2. Therefore similarly we will have 12 minimas. Therefore we clearly get an idea of the total maximas and the minimas just by getting an idea of the path difference at 4 points, and then generalizing the finding out the path difference vaguely as lambda or 2 lambda at some places between. So final answer for the total number of maximas and minimas captured comes out to be equal to 12 and 12 maximas and 12 minimas. For the B part of the question, we have another two sources S1 and S2 again vibrating in the same phase. The distance between them is given to be 2 lambda. We need to find the nearest point from S2 on this line L1, where we hear minimum intensity of sound, that is we have a minima. So for finding out that, we again utilize the same method. The path difference at this point is 2 lambda, because the wave from S1 has to travel a distance 2 lambda to reach here. Therefore the path difference at this point is 2 lambda. The path difference at infinity along this line will be 0, because since that point is infinity, these 2 points, you can imagine, this line becomes almost straight, therefore the path difference becomes equal to 0. Therefore the path difference would have increased slowly and would have been lambda somewhere and then 2 lambda over here. Now we need to find out the nearest point from S2 where we hear minimum intensity of sound. So wherever we hear minimum intensity of sound, it has to be odd multiple of lambda by 2. Now lambda by 2 would have occurred here, 3 lambda by 2 would have occurred here. So the point we are looking for is the point where the path difference is 3 lambda by 2. So we need to find out this nearest point now. Let us draw the diagram clearly. We have S1 over here, S2 over here, and this is the line L1. Let that point be at a distance x from here. This is 2 lambda. Now the path difference can be written as, this length is 4 lambda square plus x square root over. Therefore we write root over 4 lambda square plus x square minus x, that is the distance travelled from S2 to this point by the sound wave. This path difference will be equal to 3 lambda by 2. On solving this equation, we get x is equal to 7 lambda upon 12. So final answer for the nearest point from S2 on L1 where we are minimum intensity of sound comes out to be 7 lambda upon 12, and this is our final answer. So from these two parts, you must learn to write the path differences in this fashion. if you find out path difference over here to be 0, here to be 3 lambda, therefore definitely at some point over here we will have path differences equal to lambda 2 lambda, and similarly if we would have found out path difference at infinity to be 0 and at this point to be 2 lambda, we would definitely have path differences of lambda by 2, lambda, 3 lambda by 2 at some points over here on this line. So final answer is we have 12 maximas and 12 minimas over here and 7 lambda by 2 as the point as the distance of the point we require.